Why do we apply surface treatment to stainless steel? Yeah, well, like any other process, surface treatment is used because we want to obtain something. And we can divide it roughly into two different groups: mechanical surface treatment and chemical surface treatment. And this small lecture is going to deal with the second part. The mechanical we always, almost exclusively use because we want to you want to give it a different appearance, you want it to look nice, you want it to look shiny, bright or matte or so. Like for instance this elbow, which has been very finely brushed, ground, simply because we want it to look nice. The chemical department is completely different. Usually it doesn't look that nice, but on the functional side we want it to work well. We want to enhance the properties, usually the corrosion properties of the stainless steel, and that's why we use a chemical process. And of these, by far the most important one, that's a pickling. Pickling is normally done in combination in between nitric acid and hydrofluoric acid, usually like 15% nitric acid, a couple of percent of hydrofluoric acid. And the most important thing about a pickling is that it takes away what we call heat tintings from the weldings of the stainless steel. Welding is a very, very normal way of assembling pipe systems, like here. And these nice bluish heat tintings are actually, you can say, a selective risk, especially for pitting corrosion of the steel. So by taking away the heat tintings and the underlying dechromed layer, we actually enhance the corrosion resistance of the steel as compared to as it looks now. How bad it can be, we see from this one. This is some people will actually say it's beautiful. I do, for instance. Most people will not. It's a 4-inch tube which has been equipped with, in this case, 1, 2, 3, actually on a half welds here. And what you can see is a lot of rust around the welds, and you can also see, if you look very closely, some very, very nice, quite nasty actually, pinholes. And a lot of these ones have been penetration. Why? Why do we have the pitting corrosion here? Why is it not here? Because if you look very carefully, all the zones around the welds, they are tinted. They've got this nice bluish heat tinting, and that is the weakness, and that's why we get the corrosion right here. It's just like a fishing line. This is the weakest spot, and therefore it breaks here. This is a really neat example. Customers usually don't like that. Second process, that's called a passivation. The passivation is usually done in like a 20% nitric acid. So chemically it looks a little like the pickling, but there's no activator, no hydrofluoric acid. And the only purpose of the passivation is just to strengthen the natural oxide film, these 10 nanometers of chromium oxide, which protects the stainless steel. It's not visible when you are done it, so it's very, very hard to see it on an example. And the same thing applies for the third process called decontamination. The decontamination is usually done in a very weak acid as compared to the pickle or the passivation, because that's usually like a 5% citric acid or like 1% acetic acid, oxalic acid. And it's like a dishwashing. It just takes away all the impurities, and that's actually what the different medical plants, pharmaceutical plants, and the dairies are doing when they're cleaning their equipment. So it's a very advanced dishwashing. And then the most advanced process for chemical surface treatment, that's called electropolishing. And that's made in a bath containing a lot of sulfuric acid and a lot of phosphoric acid, and usually at a pretty high temperature, and then an external rectifier to push a lot of current through the system. And in the end, after like 10-15 minutes of treatment, you get this super, super bright surface, which on the one hand looks incredibly nice, and on the other hand has the absolutely best corrosion resistance you can get from this particular type of stainless steel, usually applied to the austenitic stainless steel of the 43 and the 44 class, but even the ferrites and the duplex steels can actually be electropolished as well. This is my personal favorite. Of course, it's the most expensive one as well. But it's the only one which combines the functionally thinking engineers and the aesthetically thinking architects. Everybody loves electropolishing. So we have 4 different processes. We got the pickling, functionally probably the most important, passivation, decontamination, which is, you can say, used on a daily basis, and finally electropolishing, which gives us a perfect surface.